Okay, I want to take some time to go over the 10-5 practice, trigonometry, and areas. And these are areas of regular polygons. The formula for the area of a regular polygon is 1/2 the apothem times the perimeter. Perimeter, of course, is the distance around it. In this case, this one would be 8 times 8, which would be 64, but we've got to find the apothem. So what I do in all these problems, these aren't hexagons and regular triangles where you have special right triangles, 30, 60, 90. It's not a square where you have a 45, 45, 90, but the same triangle we use on each one, okay? We use the same type of triangle, but the measure of the angles are different. So what we have to do first is, and here's the way I've worked them out, and I'm going to show you my work and how I did this. I draw this portion. See, you just have to imagine this is an octagon going all the way around up here, an octagon. This would be the center of that octagon. The center angle was 360 divided by 8. We did that on 10-3. We had to take the number of sides on 10-3. We had a picture. Let me see. I've got it sitting here, and I'll show you. 10-3, we had these pictures where we were finding the angles. The angle between these two sides was 45, and then we divided it by 2 is 22, and then we can subtract that from 90 to get that 67. So this is what we're doing, but I'm just drawing this triangle at the bottom, the triangle at the bottom, this triangle at the bottom. That's what I'm drawing, okay? And then, because that's what's important, that's what we need in order for us to find our apothem, okay? That's the apothem that we need for the formula, 1/2 the apothem times perimeter. So there's different ways that we have to go about finding that apothem. Okay, so in this particular problem, what I did, it's an octagon, so it would have been 360 divided by 8 is 45. Then the apothem drawn perpendicular to the side makes that 22.5. Okay, and that's 22.5 in this right triangle or in this right triangle, either one you want to look at. The length of the side of the octagon was 8, so that's been bisected in 4 and 4, so these sides at the bottom of these triangles are both 4. So in this right triangle, this side is 22.5, the side opposite it is 4, the side adjacent to it is A. Opposite and adjacent is tangent. So the tangent of 22.5 is opposite 4 over A, and then I just solved for A, and A was 9.7. There's the apothem, 9.7 meters. The perimeter, of course, I've already done that up here. Perimeter was octagon times with 8-meter sides is 64. So then for the formula, the area is 1/2 the apothem, 9.7, times the perimeter, 64, and I got 310.4. That's my answer, 310.4. Now there's some rounding that's going on. This 22, the tangent of 22.5, of course, I rounded this to the 10th, and then when I plugged it in here, it's rounded. So those are the answers if we round each piece to the 10th, and that's what we're going to do. Now, those answers aren't going to be the same as if the answer you might look up on the internet and write down on your answer sheet. Okay, so that's how I know that people are just finding answers somewhere on the internet and writing those down instead of working the problems, and that's not doing you a whole lot of good. When you take your test, you're going to have to show me how you worked out that problem, okay? And if you can't show me how you worked out that problem, then I'm not giving you credit for that answer, okay? And I know even on the test, you can look and find answers somewhere, but you're going to have to be able to display how you did this work. Number two on 10-5, this time this figure was a pentagon. A pentagon, all right? Why do I need to know pentagon? Because I got to find that angle at the top. Remember, 360 divided by 5 is 72, so that angle is 72. Bisected, this angle is 36, or these two angles are both 36. In this right triangle, they showed me the, this time, instead of giving me the length of the side, they give me the radius. This segment is 6, okay? So that's the hypotenuse of this right triangle with an angle of 36. I need to find the apothem. The apothem is adjacent to 36. That's the hypotenuse. So I use cosine. The cosine of 36 is A over 6, the adjacent over the hypotenuse. So the apothem is 4.9. I rounded it to 4.9. Rounded the nearest tenth. I also have to find the sides so I can find the perimeter. Well, I can get this x, the opposite of 36 down here, by using trig. It's the opposite over the hypotenuse. So the sine of 36 is x over 6. The sine of 36 is x over 6. And I get the x is 3.5. So if that's 3.5, the length of the whole side of the pentagon is 7. That means then the perimeter, it's a pentagon, 5 sides, times the side 7, is 35 feet. Now I have the two things I need, the apothem, which is 4.9 feet, and the perimeter, which is 35 feet, and I plug it into the formula. The area is equal to 1/2 the apothem, 4.9 times 35, and the answer was 85.75 feet squared. Okay? The thing that was different is they gave me a different part of this triangle. Okay? Instead of giving me the side like they did in the previous problem where they gave me the side was 8 and divided by 4 and just had to find the apothem, they gave me the radius of the pentagon, which was the hypotenuse of these triangles. And I had to find both the apothem and the length of the side to get the perimeter. Okay? The next problem, this one was a nonagon, a 9-sided polygon. So I draw the same triangle. The angle at the top this time is 360 divided by 9, which is 40. 40. Being bisected, these would be 20. Again, they gave me the length of the side, so this is easier. When they give me the length of the side, it's a little easier because I only have to find one thing, the apothem. Because I have the side times 9. The side times 9, or 14 times 9, is 126 is the perimeter. I got that. Now all I need to do is find the apothem. Well, the side has been bisected to give me 7 and 7. All I have to use is this angle that's 20. It's the opposite over the adjacent. The tangent of 20 is 7 over A. The tangent of 20 is 7 over A. So the apothem is 19.2. Now I have the apothem. I had the perimeter. So area is equal to 1/2 that apothem, 19.2, times 126. And the answer is 1,209.6 centimeters squared. Now, I'm just like you. I can go out on the internet and look for answers, and I find that answer, and I looked at how they did the problem. They didn't do it like this. They used something called cotangent. We haven't covered cotangent. We've only talked about sine, cosine, and tangent. So see, just looking at the internet is not really going to help you. You need to pay attention to how I'm showing you how to do these problems, and not just writing down answers. You've got to know what you're doing, and in order to do it right on our test. Okay, the next problem, number 5. It's another pentagon. Okay, so it's going to be a lot like number 2 up here at the top. The angles are going to be 72 and 36. Those are the angles we need, because 5 into 360 is 72, divided by 2 is 36. Get the same triangle. They said it had a side length of 10. Okay, good. We didn't have to start with the radius. It's the easy one. When they give us a side length, that's the easy thing. So we just say 5 and 5. Using 36, 5 is opposite, A is adjacent. So it's the tangent. Tangent of 36. First, the perimeter was 5 times 10 is 50. That was easy enough. And then we had to find the apothem. The tangent of 36 is 5 over A. And solving that using trigonometry, A is equal to 6.9. That's what we'll round it to, 6.9 inches. And then the formula, area is equal to 1/2 the apothem times the perimeter is 172.5 inches squared. Okay, so that's real simple. Shouldn't be hard to do. Some of you may need to go back and work some of these problems again after this and make sure that you follow me. The big thing is setting up your triangle so that you can find the parts you need, an apothem and a perimeter. An apothem and a perimeter. Those are the two things you need to put in your formula. But you have to use some trig in order to do that. The next one, number 7, says we got to have a decagon, 10 sides. If it's a decagon with 10 sides, then the angle at the top, 360 divided by 10 is 36. Divided by 2, that angle is 18. Okay? In the decagon, they tell us the radius again. Uh-oh, that's the hard one. That's when we got the hypotenuse of our right triangle. So we have to find our apothem and we have to find the side. So if this is 18, to find the apothem, we'll use A, the adjacent, over the hypotenuse, 5. Okay? So the cosine of 18 is A over 5, So the apothem is 4.8. And we round it to the nearest tenth. That way we'll all have the same answers. We round to the nearest tenth. There's no reason why we wouldn't have the same answer. But the answers the book has, sometimes they don't round, and those answers are a lot different. If we were in class, we'd worry about the book's answer. We'd make sure that we didn't. But here I'm going to try to make it as simple as possible by rounding to the nearest tenth every length or side you find, and that way all of our answers will be the same if we all round to the nearest tenth each time. Okay, then we've got to find the length of the side. Well, we've got to find this segment, x, the opposite of 18. So we use the opposite over the hypotenuse. Sine. The sine of 18 is opposite x over the hypotenuse 5. Remember, 5 is the hypotenuse in our triangle. So x, the length of that, half the side actually, is this, is 1.5. So 1.5 and 1.5, the sides of this figure, the sides of this decagon are 3. So our perimeter would be, since it's a decagon, 10 times 3, or 30 millimeters. So there's the perimeter. That was my apothem. So 1/2 the apothem, 4.8, times the perimeter, and it was 72 millimeters squared. Now I know you can watch all these and look at each one, but it might be a good idea to work one of these by yourself and check your answers rather than just watch the video if you're going to learn how to do this. The next one, number 9, is a 20-sided polygon. A 20-sided polygon. So 20 sides means that 360 divided by 20 is 18 for the big angle. Half of that's 9. There's my triangle. Again, they give us the radius. That's the hard one. That's when we have to use sine and cosine. We have to use cosine to get the apothem, sine to get the side. See, when they gave us the side, all we had to do is find the apothem, and we used tangent to do that. Okay. All right, so again, that's the hypotenuse. So we use the cosine of 9 is apothem a over 3. Cosine of 9 is a over 3, so a is 2.296 or 2.96. We round it to the nearest tenth, it would just be 3 because that 9 would round up, so I just left it as 2.96 for that reason. Or you could just leave 2.9 if you wanted to, just because I said round to the nearest tenth. Then we have to find the length of the side here. So I have to find this side, segment x. So I use the sine of 9 is opposite over hypotenuse. Sine of 9 is x over 3. So x is equal to 0.5. 0.5 is what it rounded to, 0.5. Well, if that's 0.5, the side is 1. So the perimeter will be 20 times 1, or just 20 inches. That's the perimeter of this 20-sided polygon. So then the apothem, and I left it as, like I said, 2.96. The perimeter is 20, and I got 29.6. So your answer may be a little different from that if you just said 2.9. We could be a little different from my answer. Okay, but a lot of the answers that were turned in were a lot different from mine because I don't know if you worked them out and rounded different, or if, like I said, a lot of people, I think, looking at the answers on the internet, just copied those down. And that's not going to help you when it comes time to show your work on a test. All right, then we look at number 10, or number 11, I'm sorry, we're doing the odd ones. It's an 18-sided polygon. So notice every one of these is working the same way, except some will use tangent, some will use sine and cosine because we have to find more information. This one, they give me the perimeter. Well, if they gave me the perimeter and it's 18 sides, then the perimeter divided by 18, the side would be 3. So this is 3, so they're 1.5 apiece in my triangle. The angle, of course, is 360 divided by 18, so this is 20. So this angle at the top is 10. And I have the opposite, so I just need the adjacent. So this time I get to use tangent. The tangent of 10 is 1.5 over a. The tangent of 10 is 1.5 over a. So a, the apothem, is 8.5. They gave me the perimeter, so 8.5 times the perimeter is 229.5. That's what I get by rounding. So all of those problems of finding the area of a regular polygon work in the same way. Now, if it were a regular hexagon, we have a 30-60-90. If it's an equilateral triangle, we have a 30-60-90. If it's a square, you have a 45-45-90. And that's what 10.3 mostly focused on. But 10.5, we have to use a little trig to find either the apothem or the perimeter we need for the formula. And it depends. Did they give me the radius? Did they give me the side? They never seem to give us the apothem. They always give us either the radius the length of the side, and in this past problem, they gave us the perimeter so we could find the length of the side and then go on from there. Now, the next problems, 12 through 17, these are really simple. They're hard to mess up. It's a simple formula. When you have side angle side, you have two sides and the angle included, using trigonometry to find the area. And I write it different ways. I think the book says 1/2 BC sine A. It really doesn't matter. It's these two sides, B and C, or A and B, or C and B. It didn't matter. And then this would be the sine of the angle, the included angle. So it's side, angle, side. These are the sides. There's the angle, the sine of the angle. So all you do is just plug in the formula and solve those. So number 12, the two sides were 4 and 6, or 6 and 4, and the angle is 68. Calculate that, 11.1 meters squared. So easy. It's so super simple. Okay, now if we're in class, I would show you where they derived that, why this formula works, but for now, we'll just need to know that formula. Actually, we have area is equal to 1/2 base times height. That's the normal formula we use for the area of a triangle. This trig formula, when we have side, angle, side, and there's another one where we have side, side, side that we'll look at later. Number 13, in this one, it's just 1/2, 11 times 12, sine 33, 35.9. 14, we'll just look at these answers. 17.8 centimeters squared. 15, 22.4 feet squared. 16, 46.4 millimeters squared. And number 17, and I didn't circle my answer, 86 inches squared. Now, I haven't checked my answers other than doing them. I may have made a mistake somewhere, so if you have questions about an answer, you don't think I did something correct, chat with me, text with me, whatever, send an email, and I'll try to correct it and try to send it out for everybody that I had made a mistake on that one. Okay. All right, number 18. They just walk us through the whole process. That's all they're doing, is showing how you go from one step to the next step. We're walking through the whole process. For instance, in that picture, and I try to recreate the picture over here, this is an octagon, 1, 2, 3, 4, 5, 6, 7, 8. They're just walking you through the whole process that we use to solve those problems at the top. They first ask for the measure of angle FXE. Well, FXE would be that central angle, the angle that's formed by two radius. So it's 360 divided by 8, because it's an octagon. 360 divided by 8 was 45. Then they wanted the measure of angle YXE, which is half of that angle. 22.5. So 45 divided by 2 is 22.5. Then they're asking us to find different portions, okay? They gave us 6 centimeters here, which is the radius, right? It's the length from a vertex to the center. And then we're supposed to find some other segments like XY. Well, XY is the apothem. Well, if I've given this angle is 22.5, 6 is the hypotenuse, A is the adjacent, so I use cosine, right? The cosine of 22.5 is A over 6. So the cosine of 22.5 is A over 6, so it's 5.5. And this is just what we were doing up there in those previous problems when we were trying to find the whole area. And we're finding the area. They're just walking us through it slowly on this problem, reminding you of all the steps you have to take to solve these. Then they want to know the measure of FE. Well, we can't just find FE, but we can find this segment I'm calling X. And then FE, which would be the side, S, the side. Usually they use S for the side of a regular polygon. I always just call this X. We got to call it some unknown. So to find this X, that's the opposite over the hypotenuse. So it's sine. Opposite over hypotenuse is sine. The sine of 22.5, the sine of 22.5 is X over 6. So X is 2.3. So that means that FE would be 2 times 2.3, or 4.6 centimeters. 4.6 centimeters. Then the next thing they asked us for is the perimeter. Well, it's an octagon, right? So it's 8 times the side, 4.6, 36.8 centimeters. And then to find the area, 1/2, that apothem we found, 5.5 centimeters, times the perimeter. So we got 101.2 centimeters squared. So all they were doing on this was walking you through answering each part that you had to use to solve for that problem. Like it's not much different from the other problems we had 1 through 11. It's just they're just breaking it down to take you step by step through it. Number 19 is a word problem, and it's again about an octagon. It said the octagon was were popular in the 19th century. One reason was that an octagon with the same perimeter as a square enclosed a greater area than the square, to the nearest degree, nearest foot, square foot, I'm sorry. Find the area of the octagon and the area of the square with a perimeter of 80. All right, now the area of an octagon, we just got through doing that. We know that the angle at the top, the central angle, would be 45. And see, we do these same ones over and over again, so it gets kind of, you get used to this. This would have been 45, that would be 22.5. It said that the area, they give us the area this time. Well, no. Find the area of an octagon and a square with a perimeter of 80. They give us the perimeter, I'm sorry. So if the perimeter is 80, the length of the sides are 10, right? Because the perimeter would be 8 times the length of a side. So if the perimeter is 80, we divide by 8, and the side is 10, okay? If the side is 10, then in my triangle with the 22.5 degree angle, these are 5 apiece. And now I just need to find the apothem to find the area, okay? And that's going to be opposite over the adjacent. So the tangent of 22.5 is 5 over A, and my apothem will be 12.5, or I'm sorry, 12.1 feet. 12.1 feet, that's the apothem, okay? We already know the perimeter is 80, so here's the formula. 1/2, 12.1 times 80, 484 feet squared. 484 feet squared. Now, the thing about a square, we don't have to worry about the apothem and the perimeter. We can kind of slide on that, because if the perimeter is 80, then each side was 20, and we can just use 20 squared. 20 times 20 is 400. Now, we could do the apothem, because remember, in a square, 360 divided by 4, this would be 90. So these would be 45, and it's a 45, 45, 90. So our apothem would be 10, just like halves of the sides would be. So we could have used the area equals 1/2 the apothem, which is 10, times the perimeter, which was 80. That's 800 divided by 2. It's still 400. But why do that? I mean, you know, there's a simpler formula, just the sides squared, that we could use. So, but, you know, it's a regular square, is a regular polygon, so we can use 1/2 the apothem times perimeter. It would still work. All right, number 20. Another word problem, and it's not too hard. This is just one of those triangles. It's side angle side, side angle side. So it's 1/2 of the sides multiplied together and the sine of 25. And I get a really big answer. But it said round to the nearest 1,000, the nearest 1,000 feet. So it's 1/2 of 3,000 times 2,500 times the sine of 25. And I got the answer right there. Okay. Looking at the answers that have been turned in, everybody got these answers correct. I hope that you worked them through and got those answers and truly got it right. I'm not saying that everybody's cheating at all, because I know that some of the answers have varied, and I know that people are working to understand it, but I think there's a lot of people that are just trying to get something turned in, and for that reason you're not going to understand this, and you're not going to know how to show work when it comes time to take the test. And because of that, if you don't show the right work, I'm going to grade these tests strictly. You're going to have to show work. It's the only way that I can do this. Yeah, can you cheat and solve that, share that work? Probably. But still, you're going to have to show work. All right, number 21. This is a equilateral triangle. In an equilateral triangle, remember the angle here, this is a 30, 60, 90 triangle. This is the 60-degree angle. That's the 30-degree angle. They give me the hypotenuse is 6. So that means the apothem, which is a short leg, is 3. And the long leg is 3 square roots of 3. So the whole side would be 6 square roots of 3. So the perimeter is 3 times 6 square roots of 3, which is 18 square roots of 3. That's the perimeter. The apothem was 3. So 1/2 the apothem, 3, times the perimeter, 18 square roots of 3, is 27 square roots of 3 inches. they didn't say how to, well, they did say round to the nearest tenth, so it's 46.8 inches. 46.8 inches. The next one, another hexagon. See, these are the easy ones. Equilateral triangles and hexagons are the easy ones because they're 30, 60, 90 triangles. This is a 30, 60, 90, but the 30 is at the top, 60 is at the bottom. They gave us the length of the side was 12, so 6 and 6. That's the short leg. That's the long leg. The apothem is 6 square roots of 3. The perimeter is 6 times 12, which is 72. The apothem is 6 square roots of 3. So there's the way we would solve it, apothem times perimeter. And I got the area is 216 square roots of 3 inches, or 374.1. Your answer might be a little different if you round different, but it shouldn't. Everybody's answer should be exactly the same as mine, regardless, because we're rounding to the nearest tenth. And the next one, a more complicated problem, of course, because we got a pentagon. It's not one of those special right triangles. Pentagon, again, we've done pentagon just like we did octagon on the previous page. We've done those a lot. The angle at the top was 72. 360 divided by 5 is 72. Bisected is 36, so these two angles are 36. They gave me the length of the radius, which is 16, which is the hypotenuse of my triangle. So I got to find the apothem, which requires me to use cosine of 36 is a over 16. Cosine of 36 is a over 16, so 12.9 is the apothem. To find the length of the side, I have to use the sine, opposite over hypotenuse. The sine of 36 is x over 16, so x is 9.4. That means the length of the whole side is 9.4 times 2, which is 18.8, times 5 would be the perimeter. And I know I'm going through this fairly quick, but we've answered so many of these by this time. I'm hoping that you understand. You can work these and go back and look at my work and see if you agree. We're rounded to the nearest tenth on these, so your answer is 12.9 times 94 divided by 2, and I got 606.3 inches squared. Now, if you try this several times, or if you multiply mine and get a different answer, then you need to let me know if I made a mistake. But because, like I said, I haven't been able to check these. Okay, so that was number 23, and then we skipped ahead to 26 and 27. Because if I was in class, we'd definitely do more of these type of problems. Or to number 26, we didn't do 27. I don't have 27 worked out, do I? Okay, number 26. They want to find the area of the shaded region, which is involving two pentagons, and they give us the radius in each one. So this is a long problem. We got to find the area of the white one with a radius of 5, and the area of the larger one with a radius of 7. Okay, so here's my work. I have to find the radius of the smaller one, to find the area of the smaller one with a radius of 5. Remember, these are pentagons, so the angle at the top was 72, so these are both 36, but they're both the same triangles. It's just the hypotenuse is different in each one. We use the cosine to find the apothem 4. The sine, opposite over hypotenuse, to find the side, 2.9, so I got the side is 5.8, and the perimeter is 29. Came out to be 29 when I round and everything. In this one, the apothem, same thing, cosine of 36 is a over 7, so it was 5.7 for the apothem. For the side, I used the sine of 36 is opposite over hypotenuse, 4.1. So the perimeter here is 41. And then over to the side, I use the apothem times perimeter for the pentagon, the 5-sided, or the one with a radius of 5. They're both 5-sided. It's 58 area. For the one with a radius of 7, it had 116 area. So 116.9 minus 58 left me with 58.9 meters squared. So that was the outside area. And it's kind of odd that that outside gray area is actually larger than the white area inside. But that's the way it worked. That's what it came out to be. All right, I hope this will help you. Please go over these, and if you have any questions, remember, send a chat or an email message, and I'll try to help you.